All right, so yesterday in class I handed out your notes to you. I hope the memorization is going well. Remember, you really want to keep working on that. Notice the daily planner has it up. And what I would like you to do is right now open your notes and you're going to see lesson 1. We're going to be looking at squares. So as you guys are watching this video, you're going to see some stuff, and if you have questions, I just want you to remember that you can always pause the video as you're watching it so that you can see and get some questions. But the key thing today that we're looking at is understanding the inverse operations with squares and cubes and evaluating squares and cubes of small perfect square and cube numbers. So one of the things that I really want you to think about is when we look at a square, what are we looking at? We're looking at a length and a width. And what do we know if it's a square is we know that these two same sides are the same height. Another word that we often see associated with these is base and height. And please make sure you're writing these in your notes, so if I would look at your notes and check them at the end of the unit, I'd be able to give you points for kind of filling some of this in. Another word you might see used is the side of the squared, so side times side. Now the key thing with the square is we always want to look at the area. Now, area of any rectangle is length times width, base times height, and in this case we are going to say side times side. And another way of writing that is to put it as the side squared. So key thing we know, area is equal to the side squared, which is nice in that I want you to write down the side is equal to the square root of the area. So if we know the side, the square root of the area is our side length. If we know the side, we can square it and find our area. So those are kind of some important things as we look at this unit. Now, it says you can draw a square with different areas and by connecting the points on this 5 by 5 dot paper. So if you notice this square has a side length of 1. So we're going to put S equals 1. That's our side. And notice that the area is 1. So the area is 1 because it was 1 squared, and 1 squared equals 1. But if we look at that, I also want you to put down the side of this one is equal to the square root of the area, and the square root of 1 equals 1 unit. If we are looking at this square, the side length is 2. So S is equal to 2 and S equals 2. Please make sure you write this in your notes, which means the area was equal to 4 units squared, which is 2 squared is 4. So what is our side equal to? The side is equal to the square root of 4, which is 2 units. Remembering that this 4 came from the area. So it says on the next page you're asked to draw squares and mark their areas. Not all of the sides will be vertical or horizontal. So kind of keep that in mind. And what I also want you to think is right at the bottom of your page I want you to write the word area and I want you to write the word side. If we know the area happens to be 16 centimeters squared, thinking of those perfect squares, the side length should be the square root of 16, which is 4 centimeters. If the area happens to be 20 centimeters squared, the side is the square root of 20 centimeters, and that isn't a perfect square, so we can't find that as an exact whole number like we could here. So that's going to be kind of important as we go forward. Now, the first one you're asked to draw, and what I would have you do, and you're also going to see these notes online, so if you go to the daily planner, they're there. I would like you to just take a couple minutes and please pause the video. And as you pause the video, you are going to try and draw an area with 4. Now, the area of 4, the easiest thing to do is look back at the last one. This was an area of 4. You can place it anywhere on that dot paper. This is when you count the area of 4, 1, 2, 3, 4. It has to be a square. It cannot be a rectangle. So make sure you are drawing a square. So now you want to draw 9, then 16. And I would have you do that. And right below each one, you're going to put the area and in this case is 2 squared. And then you're going to put the word side equals, and we would say 2 centimeters. Area is 9, side is equal to 3 units. So please draw a 3-unit square. Area 16. What number squared gives us 16? The side is going to be 4 squared. So the side is 4 units. Draw your squares, and then I want you to think about, you got to make a square with an area of 2 units. So it only wants 2 of these, and I don't want a rectangle. And here is the hint. Tilt it. So try it. Everyone try. If someone gets it, just kind of, you can show some of the people around you, and then after you're done pausing the video, you're going to see mine. So you can see I drew my 3 by 3 and my 4 by 4 square. This is a square with an area of 2. Now, when I'm talking area of 2, I'm counting these 2 together on the top. That makes 1 area. That makes 1 square. Like if I take this triangle right here, that's kind of shaded red, and I place it over here, that would make 1 square unit. Same with down here. This is my 2nd square unit. So this has an area of 2, which means if I was looking at this, the area of 2 means the side now has to be, well, how did we get 2 here? We took the square root of 4. To get 3, we took the square root of 9. To get 4, we took the square root of 16. So what is our side length here? We're going to leave it this irrational number, square root 2 units. I want you to think now, how could you draw 5 and 8? And remember, if you sometimes start with a center square on these, so like if I start with this one being in the center of it, I sometimes then can, that's my 1. And now I got to figure out how to get 4 more units. And this is tricky in that if I look at this triangle, I'm now going to make another triangle like that. But now this time, I'm going to go down to, oh, this is not that easy on my tablet. You'll get to see when you get to try the tablet, to this point. Okay, so these two triangles right here, that makes an area of how much? That makes an area of 2. This is going to be an area of 2 units. So now I just need to make another triangle like that. So I'm going to go to this point. Okay, and then I'm going to go up here. Now, sometimes it helps to have these drawn inside, and for some of you it doesn't. Try the 8. You will see it posted on my notes, but I'm not going to do it for you right now. But I just want you to see it, and we'll pause this. And again, we want to think about what is our side length and what is our side here. So you can pause the video and have everyone try it, and then I'm going to draw it so that you can see it. And some people actually have an easier time drawing the 8 and the 2 than the 5. But the side length here is square root 5 units. What's our area here? Square root 8 units. Now, we're going to look at some definitions, and again, if you need to pause this for drawing or help each other draw theirs to fill in your notes. The notes are also online. Which squares were the easiest ones to draw, and which ones were the most difficult? Well, I think most of you are going to find that the upright squares, and what I mean by upright was the ones that were just like this, were easier to look at. Those are also our perfect squares, and our difficult ones were tilted. The difficult ones, and I'm telling you guys, this stuff is kind of hard at first, but you'll get better, don't worry. It says, how did you determine if your drawings were actually a square? Well, remember, what makes a square? The sides must be the same length. So our sides must be the same length going around. What else do we know? We need to have a 90-degree angle in the corner. So all of our squares have to have a 90-degree angle, which is a right angle, right? Sometimes we say we need a right angle. And if I look back at this, I need to just check if I'm making sure Is this a 90-degree angle? Is this 90 degrees? Is this 90 degrees? And that's what I'm looking at when I try to see that. My drawings aren't perfect, but you can see if I would have had a nice straight edge, those would actually be squares. It says, how do you find the area of a square? Well, we kind of talked about this earlier. One way to find the area is we can count the little squares inside. If you didn't want to count each of those little squares inside, we could use a formula, right? And our formula is side, I had it on that first slide that we saw, side times side equals area. Now, it says how long are the sides of the squares we drew earlier? So, how long are the sides? Remember, what was our area of our first one? The area of the first one was equal to 1 centimeter squared. So we had it's not 1 squared, trying to erase here, sorry. I had 1 centimeter squared, I had 4 centimeters squared, and I had 9 centimeters squared. With those areas, the side was 1 centimeter, 2 centimeters, 3 centimeters. When our area changed to the area being equal to 2 centimeters squared, 5 centimeters squared, and 8 centimeters squared, the side length was square root 2 centimeters, square root 5 centimeters, and square root 8 centimeters. As you are looking at this next page, I'm going to just have the sub pause it and read through this with you. It's kind of some vocabulary, so you can pause it and then we will just go on after you are done reading. So make sure you pause that and read through it with the students, please. And then the last one is talking about, well, how about our square roots? So if you drew a square that had the areas 1, 4, 9, 16, 25, how long would each side be? Well, remember, to find the side length, we take the area and we take the square root of the area. So our answer should be the square root of 1 equals 1. The square root of 4 is 2, 3, 4, and 5. So each one of these. It says if you drew squares with an area of 2, 5, 8, and 12, how long would the side be? So how long would the side be? Well, remember, we're going to take the square root of our area. Square root of the area means square root of 2, square root of 5, square root of 8, and square root of 12. Now, these are not perfect squares. So unlike up here, where we could say the square root of 4 equal 2, the square root of 25 was equal to 5. We can't find this exact. It's a decimal. It says, so let's mark the numbers on the line below. Here's what I'm going to do. I'm going to just have you pause, or you'll see me put these up in just a minute. And so here you now see all of these marked. Kind of make sure if you need to pause the video to put all yours on. 1, 2, 3, 4, 5, square root 2, square root 5, square root 8, and square root 12. Now, you should be able to do this if I give you a quiz Monday. And what I'm probably going to ask is for the 10 squares and 5 cubes. Here's what your homework looks like. When you start your homework tonight, make sure you use your notes. So use the notes, because you're going to see a square drawn with a length of AB. This is exactly like the tilted one, so go back to problem 2 in the notes. And remember, this is kind of hard at first. We're going to go through it Monday. We'll take our time and I'll help you out. But you're going to answer these questions. Look at length AB. Look at problem 2. Look at this one. It's up 1 and over 2. This is like up 1 and over 1. And if you're going, I don't get this, remember, you can re-watch this video and maybe it'll make a little more sense. See you Monday. Hope all goes well.